Hello friends, this video on States of Matter Part 9 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched Part 1 to Part 8. Now let's take Gay-Lussac's law. It states that at constant volume, the pressure of a fixed amount of gas varies directly with the temperature. So if my volume is constant, the pressure is directly proportional to temperature. If you increase the temperature, you increase the pressure. And that's why if you see the tire burst in summers, why? Because if you see the tires, the volume is constant, right? Volume is equal to constant. Because the volume of moles of air is constant. But in summer, the temperature increase. The temperature increase, the pressure increase. The pressure increase, it burst. So this is the reason why the tire burst in summer. The Gay-Lussac's law explains the bursting of tire in summer. So the Gay-Lussac's law says that at a constant volume, the volume is constant, pressure is directly proportional to temperature. And this relationship actually can be derived from Boyle's law and Charles' law. So we'll give a logical explanation to this Gay-Lussac law. So it says that I have one balloon, let's suppose, it's closed balloon, which has some moles of molecules. If I increase the temperature, again the same thing will happen. These molecules will start moving at a higher speed. Since they'll be moving at a higher speed, they will hit this wall at a higher pressure, right? Since they are hitting at a higher pressure, my pressure is increasing with increase in temperature. If I decrease the temperature, these molecules will slow down a bit. It will not hit the walls of balloons that high. So the pressure will also go down. Let's take one lab for this law. You take one bottle, remove the cap, make sure there is no cap in this, heat this. There is no water, nothing, just air inside this. Just heat this. So the normal air will be heated, the air will become hot, right? So I'll get hot air, correct? So once it is heated and when you will feel the heat in the air, close the lid. Now you do one thing, put some water in the tap and put this bottle here. This is my cold water. Since it is cold, now what will happen? This bottle will shrink. This bottle will shrink. It will become something like this. Why? Because just now, as I told, if my volume is constant, pressure is directly proportional to temperature. This pressure I am talking about the internal pressure. This is the internal pressure. Please note, this is the internal pressure. Internal pressure of this bottle. Now, since I have decreased the temperature here, so the pressure will decrease. Since this pressure will decrease, the atmospheric pressure will make sure that this becomes shrink like this. Because the atmospheric pressure will shrink this balloon. Correct? Why? Because the internal pressure will decrease. Why internal pressure is decreasing? Because you are making the internal air colder. The temperature you are decreasing. Since you are decreasing the temperature, the pressure will decrease. And this is something you can observe easily. You take a bottle, heat it up, close the lid, put this bottle in the water. You will feel that this bottle will shrink. Let's take the graph of the Gay-Lussac law. So here I told that my volume is constant. Since my volume is constant, I'll get the graph, and the graph will be isocourse, where the volume is constant. So for different volumes, you see the pressure and temperature graph looks like this. Here temperature is in Kelvin. it looks like this. For a higher volume, it is little more inclined. The angle is more in case of lesser volume, it is more inclined. It has more angle actually. This is lesser volume. This guy. So with this graph also I can say that pressure is directly proportional to temperature. Just by looking at this graph, pressure is directly proportional to temperature. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.